Have you ever looked out at the vast, mysterious ocean and wondered what secrets it holds? We often think of space as the final frontier, but right here on Earth, our oceans are teeming with wonders we're only just beginning to understand. And one of the most incredible of these is hiding deep beneath the waves, underwater volcanoes. Now, when you hear the word volcano, you probably picture a fiery mountain on land, spewing lava and ash. But did you know that about 80% of all volcanic activity on Earth happens completely unseen, deep on the ocean floor? These are not just geological curiosities. They are colossal powerhouses, releasing an unimaginable amount of heat into the surrounding water. This got scientists and engineers thinking, what if we could tap into that energy? What if these underwater giants could power our world? This is the incredible concept of submarine geothermal energy. It's an idea that could completely revolutionize how we think about clean, renewable power. Geothermal energy itself isn't new. For decades, we've been drilling into the Earth's crust on land, in places like Iceland and California, to harness the planet's natural heat. We pump water down, it gets superheated by the hot rocks below, turns into steam, and that steam spins turbines to generate electricity. It's a brilliant system, reliable, clean, and powerful. But land-based geothermal has its limits. You can only build these plants in very specific geologically active areas. What if the biggest, most powerful heat sources weren't on land at all? That's where our underwater volcanoes come in. Imagine a volcano on the seafloor, constantly releasing heat. The water pressure at these depths is immense, and because of this pressure, water can get much hotter than its normal boiling point without turning into steam. We're talking about water reaching temperatures of 400 degrees Celsius, or over 750 degrees Fahrenheit. This is what scientists call a supercritical fluid. It's not quite a liquid, not quite a gas, but it holds an enormous amount of energy. The theory is this: we could build specialized power plants on the seabed near these hydrothermal vents. These facilities would capture this super hot, high-pressure water. As this supercritical fluid is brought up and the pressure is released, it would flash into vast amounts of steam, far more steam than you'd get from just boiling water on the surface. This massive burst of steam would then drive turbines with incredible force, generating huge quantities of electricity. The potential here is staggering. A single, well-placed underwater geothermal plant could potentially generate as much power as a large conventional power plant. And unlike solar or wind power, which depend on the weather, this energy source is constant. It runs 24 hours a day, 7 days a week, regardless of whether the sun is shining or the wind is blowing. This makes it a perfect baseload power source, the kind of reliable energy that can form the backbone of a national grid. So if this idea is so amazing, why aren't we already surrounded by underwater power plants? Well, as you can imagine, the challenges are as immense as the ocean itself. First, we're talking about building and operating complex machinery in one of the most hostile environments on Earth. The depths where these volcanoes are found are dark, cold, and subject to crushing pressures that would instantly destroy ordinary equipment. We would need to develop robots and remotely operated vehicles, or ROVs, that are far more advanced than what we have today. These machines would need to be able to withstand the intense pressure and corrosive mineral-rich water, all while performing delicate construction and maintenance tasks thousands of feet below the surface. Everything, from the pipes and turbines to the bolts holding it all together, would have to be made from exotic, super-strong alloys that can resist corrosion and extreme temperatures. Then there's the challenge of getting the power back to shore. We would need to lay thousands of miles of high-voltage, heavily armored submarine cables across the ocean floor, navigating treacherous underwater mountains and canyons. This is already done for offshore wind farms, but the depths and distances involved in submarine geothermal would be on a whole new level. It's a monumental engineering feat that would require massive investment and innovation. And of course, we have to consider the environmental impact. These deep-sea hydrothermal vent ecosystems are unique and fragile. They are home to bizarre and wonderful creatures that have evolved to survive in these extreme conditions, feeding on chemicals from the vents in a process called chemosynthesis, rather than sunlight. We would need to conduct extensive environmental studies to ensure that building these power plants does not disrupt these incredible, one-of-a-kind habitats. The goal is to create clean energy, not to destroy one ecosystem in the process of saving another. Despite these hurdles, the pursuit of submarine geothermal energy is gaining momentum. Researchers and engineers around the world are actively working on solutions. Projects are underway to map the ocean floor in greater detail, identifying the most promising locations for future plants. Scientists are developing new materials and robotic technologies specifically designed for these deep-sea conditions. One of the most exciting areas of research is focused on so-called magma-enhanced geothermal systems. The idea is to drill directly into the magma chambers of underwater volcanoes. This would give us access to nearly limitless heat, but it is an incredibly ambitious and dangerous proposition that pushes the boundaries of our current technological capabilities. It's the kind of high-risk, high-reward science that could lead to a true breakthrough. Think about what this could mean for our future. A world powered by the Earth's own internal fire, a source of energy that is clean, constant, and virtually inexhaustible. It could provide energy independence for coastal nations and island communities around the globe. It could power the process of desalinating seawater, providing fresh water to arid regions. It represents a fundamental shift in our relationship with the planet, moving from extracting finite resources to harmonizing with its natural powerful cycles. The journey to harness the power of underwater volcanoes will be long and challenging. It will require global collaboration, significant investment, and the brightest minds in science and engineering. But the potential reward is a cleaner, more sustainable future for all of us. The next great energy revolution may not come from the sun above, but from the fiery heart of our planet, hidden deep beneath the waves. It is a reminder that some of the greatest answers to humanity's biggest challenges are waiting to be discovered, right here on Earth. Thank you so much for joining me on this deep dive into the future of energy. If you found this as fascinating as I do, please hit that like button and subscribe to the channel for more explorations into the amazing science and technology shaping our world. Let me know in the comments what you think. Is this the future of energy, or just a sci-fi dream? I'd love to hear your thoughts. See you in the next video.